Good morning, ladies and gentlemen. Today, I would like to present my study on investigation of resistance and leakage of auxiliary ventilation ducting in underground mine in Quang, Ninh. Introduction. The auxiliary ventilation is carried out by moving air to the face. Air the chuck is advised. Amount of air arrives the face decrease because the resistance and leakage of ducting system. In Vietnam, study on auxiliary ventilation are not much. There is no study on resistance and air leakage in ducting system being used in coal mines. For designing ventilation system, the parameter was given from Phuong handbook as the data published long time ago. While apparent ducts are made in Vietnam, material and technology are different. Therefore, investigation of duct parameter of ducting system in underground mine in Quang, Ninh has been undertaken. Object of study: an experimental model was connected to determine duct resistance. To derive a conceptual prediction model to evaluate the duct air leakage based on the experimental data at Quang Ninh mines. Study results have been used to optimize the auxiliary ventilation system. Measurement of duct resistance. The basic for determining duct resistance. Friction resistance in ducting system is presented by equation 1, where S pressure loss, S cross section of duct, V average velocity, L duct length. The specific resistance is presented by equation 2. Friction factor is determined by equation 3. Laboratory setup. Experimental model for determination of duct resistance was set up at Institute of Mining Science and Technology, Zinovii, Quảng Ninh. Left picture is experimental apparatus. Right picture is schematic diagrams. 5 ducts were connected directly to residual ducting and gas extractor in the horizontal direction. The fan follow the airflow into the ducts. Determination of duct resistance, assuming that the airflow in duct is turbulent flow. The density of the air is a constant. Experimental model set up the condition must be satisfy the condition. The ducting system must be kept tight shut during experimental procedure. Hence, the pressure on the ductwork was caused by frictional resistance. The test duct length shall be required to arrive at a fully developed turbulent flow. Measurement of velocity and pressure loss. The cross section of duct was divided into 4 areas, 16 points. The velocity at the center of each section were measured by pititudes. The average velocity were calculated from the mean value of V. At the same time, the pressure of section PL1 and PL2 was measured and related with the velocities. Result of determination of duct resistance. Experimental data for determining duct resistance, specific resistance, and friction factor are shown in Table 1. Average value of resistance, specific resistance, and friction factors calculated for test ducting as follows. The measure friction coefficient is much smaller with the values using the auxiliary ventilation design in Vietnam. Estimation of leakage of ducting system. Model of duct leakage. A conceptual prediction as presented by equation 1. Assuming that leakage coefficient in the ductwork can be declarable by equation 2, where leakage coefficient P, duct length L, quantity of air flow in the ducting system Q, A, B, C constants. The way to line here the equation is used to natural logarithm equation. Except of experimental data logarithm P, logarithm L, and logarithm Q under given data. Equation above can be written by equation 4. Require a regression is chosen coefficient BO, B1, and B2, such that the sum of where a result is a minimum. They driver equation with respect to model parameter BO, B1, and B2. Set them to equal to 0. Normal equation of two independent variables can be written in matrix form as solved over matrix to obtain the regression coefficient. Experimental data for the duct of 0.6 meter diameter are shown in table 2. Leakage coefficient for the duct can be obtained based on experimental data presented by equation 9. Using the F-test can evaluate the probability equal 0.0. The significant level is 0.5. So, the regression equation is validity in fitting the data. Conclusion. An experimental model was connected to evaluate the duct resistance. The measured friction coefficient is a factor is small compared with the value using the designing the auxiliary ventilation in Vietnam. Therefore, reliable estimating the friction coefficient is that important to the design auxiliary ventilation in underground mines. A conception prediction model can be determined duct leakage based on experimental data at Quang mines. The research results have been used to optimize the auxiliary ventilation system. Optimization of the auxiliary ventilation system can save costs and energy.